Hiya 12s, Mr. Lim here again, and Mr. Lim finally remembered all the memes to put on there, and we're doing some pressure, rate, and yield optimization. Alright, so we're going to be learning about how to use pressure to optimize rate and yield. Okay, so the pressure will affect the rate and yield of a chemical reaction, and optimization of the pressure is important to make lots of money. Right, so pressure and rate, so let's have a think. You'll want to have a fast rate of reaction, so a high pressure is required. Remember, you're going to be asked to explain this in using collision theory, so it is about high pressure. High pressure is usually achieved by having a high amount of reactants in the reaction vessel. Okay, so it's not as if you're just going to be like, hey, let's just turn this reaction vessel smaller to have a higher pressure. No, we're just going to just pump in more of the reactants. Okay. High pressure means collisions occur more often, so that's collision theory, which means that there is the rate of successful collision increases and thus the rate of reaction. Remember, words that imply something going over time. All right. So pressure and yield. So it depends on whether the forward reaction produces more or less gaseous particles than the reverse rate of reaction. Okay. So under high pressure, the reaction that produces less gas particles is favored. Under low pressure, the reaction that produces more gas particles is favored. Okay, so you have to look at which reaction, forward or reverse, produces more or less gas particles. Then, if you want to maximize yield, remember you wanted the forward reaction. Okay, so if the forward reaction produces more gas particles, then you want a low pressure. And if the forward reaction produces less gas particles, you want a high pressure. So remember, rate and yield are independent of each other. No matter what rate you want, if you want to have a fast rate, you want to have a high pressure. But if you want to have a high yield, you may want a low or a high pressure. Okay? So there may be a time where you need to compromise. If the forward reaction produces less gas particles, will you need to compromise? No, you won't. You will just want to increase the pressure as much as possible, but you will need to stop increasing the pressure when you're about to blow up the plant or when it becomes too expensive to maintain all those high pressure stuff. Okay, so safety and cost become your limitations. However, if the forward reaction produces more gas particles, you run it at different conditions, and then you find out what's the favorable mix of to get a high rate and a high yield. Okay, so have to find some compromise. Okay, and I think that's it. All right, so that's all. We'll see if this let's see if this comes up with another dot point.